Morning again. So let us continue topics. The fundamentals of um design. Okay, so by this time, class, so we are going to tackle thin-walled cylinder or a pressure. Okay, so by the way, class, so this thin-walled cylinder is an application of a purely tensile stress. Okay, so as previously asked. Okay. So what is a thin wall? So there is a condition for this class. Okay. Thin wall cylinder. So thin wall cylinder or pressure vessel is one whose plate thickness is small compared to the diameter of the vessel. So the ratio of the thickness to the inside diameter is equal to or less than 0.1. Okay. So take note of the class of the thickness and the inside diameter of. Okay? So, if we take a look at the section of the pressure vessel, so we will notice that there is the circumferential stress acting force where the plate is cut, of course. Okay? And of course, this force or stress uh, can be solved using the drive. Okay? So, take note class that we can easily equate, of course, this forces acting here against the force created by the pressure inside the pressure. Okay? So, we can say that the force acting, of course, at this side plus the force acting at the other, or the other end rather, will be equal to the force equal to the uh, force due to the pressure of the pressure. Okay? So, by the way, class, let us first consider what is the definition of the circumferential stress, okay? Or the tangential stress, okay? So, the fluid force acting on a longitudinal section, unit length is equal to, okay? Equal to plus the force acting. And the equilibrium of forces may be equated to the resisting force equal to 2T. Okay? So the tension class at the at one end and at the other end will be equated to the force created by the pressure. So where of course the sigma t here, so this is class the derived equation. Sigma t, of course the tensile stress. And then P, of course, the pressure, and DI is the inside diameter over. Okay? So, the pressure class or the force, of course, acting due to the pressure can be defined using the definition of pressure equals to the force over the area. Okay? Where that force now is equals to the area, of course, of the cross-sectional area class. Of course, that is the length multiplied by the diameter, the area. Length multiplied by the inside diameter. So, multiplied, of course, by the pressure. Okay? So, that is why the force now acting due to the pressure equals to PD or the pressure inside the cylinder multiplied by the inside diameter multiplied by L. So, but for the tensile stress class, knowing that sigma t is equals to F over A, where the area now resisting, of course, is this, the thickness of the plate multiplied by the length, okay? Multiplied by the Okay? So that's why L now can be eliminated. And then let's derive equation sigma t is equal to PD I over. Okay? So that is class 4, the section along the or longitudinal section. Yes? Price. So knowing that only that stress equals. Okay? So let us now proceed to the next. Okay? Now, for longitudinal tensile stress, so the fluid force now acting on ring section is equal to the 1/4 force pi multiplied by d side diameter square times p. And equilibrium to the force may be equated to the force pi d multiplied by stress, okay? Where the sigma t represents the, or sigma L rather, represent this longitudinal. Okay? So take note class that the section is along the longitudinal axis. Okay? So let us again consider the figure rather. Okay? Figure. So instead class of cutting this way, so is of course parallel to the diameter. The section is parallel to the diameter of the plate or the pressure vessel. Okay? So that is why class the formula derive same formula or same equation rather sigma, but the formula is different of course. So the for longitudinal stress that is P divided by di over 4t. So we know class that the for tangential the failure is PD over 2t. Okay? So take note class which stress or which section will fail first. Okay? Okay, so of course the failure of course is along the tangential, okay? The tangential failure or axis rather. So that is the first failure. So because if you look at the same value of P over D, P multiplied by D divided by 4 and PD over 2, of course the value of stress for the longitudinal is only 1/2 of the value of the stress in tangential. Okay? PD over 40 plus. Okay? So, let us now consider the joint efficiency or the relative strength. So, what is the definition? So, joint strength is the ratio class, not ratio, of minimum strength of joint to the strength of solid plate. Okay? So, for the efficiency, minimum strength of joint divided by the strength of solid plate. So, take note class, strength of solid course maximum. Okay? Maximum strength of the, okay? And then, so, considering now the equation or the efficiency, sigma t is equals to PD over 2t multiplied by n. And for the longitudinal stress, sigma L is equals to PD over 4t multiplied by, okay, so take note class, the failure of the pressure vessel is uh, along only the circumferential and along the long. Okay? There are two failures that may be considered. But the first failure to occur, of course, is the circumferential along the circumference. And let us now consider an example. Okay, it's a 10-walled cylinder. Example, a water reservoir, 24 meters high and 12 meters diameter is to be filled with water. Okay. Find the minimum thickness of the reservoir rating if the tensile stress is limited to Pascal. Okay. Take note, class, this is under hydrostatic pressure. Okay, so the hydrostatic pressure now is equal to the unit weight, of course, of the water multiplied by the height. Okay, so getting now the pressure of the water at the bottom of course, reservoir. So the pressure is now 235 or 0.2354 gigapascal or Newton per millimeter. So, considering now the equation, so the tangential stress is equals to PD over 2T. So, or the thickness now is PD over 2 multiplied by the stress. Okay, so substitute now the value of the given. So, the thickness now is equivalent to 28.25 millimeters. Plus, and then another, we have here a spherical. So, take note, class, that the first example is an application of the tangential stress. And here is along the longitudinal stress. Okay? So, a spherical pressure vessel of 400 millimeter diameter has a uniform thickness and an internal pressure of 8,000 kilopascal. Its stress of the material is 420 gigapascal. What is the factor of safety? Okay, class. So, take note that the stress over factor of safety equals PD over 40. Okay, so again, class, substituting values, ultimate stress is equals to, or the, yes, it is 420 megapascal, then 4 multiplied by 10, so the thickness, then 8 divided by 400, diameter of the, so the factor of safety now, class, is 5 point. So, thank you very much, class. Okay, again, thank you.